So we continue looking at organic chemistry, and today we're going to look at the alkenes. So what you must know about the alkenes is that these are hydrocarbons, and that means that they are made up of hydrogen and carbon atoms. So the first thing that you must know is that these are hydrocarbons. So the alkenes are hydrocarbons, and hydrocarbons, that means that they are made up of carbon and hydrogen atoms. So the other thing that you must know about the alkenes is that they form a homologous series with a general formula of CnH2n. So they form a homologous series with the general formula of CnH2n. Then the other thing that you must know about the alkenes is that they all contain a carbon-carbon double bond. So they all contain a carbon-carbon double bond. They all contain the carbon-carbon double bond. And the carbon-carbon double bond is their functional group. And this largely detects how they react. So the carbon-carbon double bond is their what? Functional group, and that largely detects how they react. So this is their functional group. Then the other thing that you must know about the alkenes is that since they contain a carbon-carbon double bond, that means that they are unsaturated hydrocarbons. So these are unsaturated hydrocarbons. And the reason why they are unsaturated hydrocarbons is because they are formed of a carbon-carbon double bond. And if you remember, we said that for the alkenes are saturated hydrocarbons, and the reason why the alkenes are saturated hydrocarbons is because they are formed of a carbon-carbon single bond. Let us now look at this table, and this table shows us the compound, the formula, the structure formula, and the number of carbon atoms. And the compounds that we're going to look at, we have ethene, propene, and butene. So we are going to start with the formula of ethene. So the formula of ethene can be written in this form. It can be C2H4. And since we know that our general formula is CnH2n, and we know that if a compound starts with eth, that means that it has two carbon atoms. So we can say C2H, then we can say 2 multiplied by 2, and that's going to give us C2H4. So that's going to be the formula of ethene. And drawing the structural formula there, we're going to draw it in this form. So we're going to have a double bond there, and we're going to have 4 bonds. So we're going to have our H there, our H, and our H. Then for ethene, the number of carbon atoms in ethene, we only have 2. Let's come to propene. Propene, the formula there of propene is C3H6, and drawing the structure formula, we're going to draw it in this form. So we're going to have a carbon atom there, it's going to have a double bond. Then since it has 3 carbon atoms, we're going to draw another carbon atom. And we know that one carbon atom must be connected to 4 bonds. So we're going to draw 1 there and 1. That means that we have drawn all the 4 carbon, we have drawn all the bonds on this carbon atom. Then to this one, it has how many bonds? It has 1, 2, 3. So to make it 4, we're going to add 1 there. And for the last one, it only has 1 carbon, it only has 1 bond there. So to balance it there, we're going to put 1 there, 1 and another 1. And after we do that, we're just going to add our hydrogen atoms. And the number of carbon atoms, we're going to put 3. Let us go to butene. So the formula there, it's C4H6. And drawing the structure formula, we know that it has 4 carbon atoms, so we're going to do that. And we know that the first carbon atom is going to have a double bond there. Then drawing other bonds that are connected to these carbon atoms. For the first one, we're just going to put extra 2. Then for these second carbon atoms, it has how many bonds? 1, 2, 3. So for us to have 4, we're just going to put another one there, which will come down. So you can put it down or up there. Then for this one, it has how many bonds? 1, 2. So we're going to put another one there and another one. Then for the last one, it only has 1. So we're going to put extra 3. So we're going to put 1 there, 1 there, and 1. And we're going to just place our hydrogen atoms. Then the number of carbon atoms, we are going to write our 4 there. Let us now look at the key points under the alkenes. So the first key point that we can talk about under the alkenes is that the alkenes are made up of the alkanes by cracking. So for example, ethene is formed by cracking ethane, and hydrogen is produced. So the first point there that we can talk about is that the alkenes, they are made from the alkanes. So the alkenes are made from the alkanes. And for example, if we take ethane, so ethane can be produced from ethane, and the alkanes are made from the alkanes through the process of cracking. So we use the process of cracking. So for example, ethene is formed by cracking ethane. And let us look at this process. And during this process, hydrogen is produced. So if we have our alkane, and we have said we're going to use our alkane, which is ethane. So if we have our ethane there, we have our ethane, and if this is cracked and we use steam, this can produce ethene, which is an alkene, this also produce hydrogen gas. So we have ethane there, then this will produce ethene plus hydrogen. So this is how the alkenes are produced from the alkanes through the process of cracking. Let us look at another point. So the second point, we're going to look at combustion. So the alkenes also undergo combustion, and they undergo two types of combustion. They undergo through complete combustion and incomplete combustion. So we're going to start with the first one, which is complete combustion. So the alkenes do burn in good supply of oxygen to produce carbon dioxide, water, and heat. So they do burn in good supply of oxygen to produce carbon dioxide, water, and heat. And we're going to use ethene as an example there. So when ethene reacts with oxygen, this will produce carbon dioxide plus water. And to balance up this equation, we're going to put a 3 there, going to put a 2 here, and a 2 there. Let us look at incomplete combustion. So incomplete combustion occurs when there is no good amount of oxygen, or there is insufficient oxygen that will react with the alkenes. And when they react with the alkenes, they'll produce carbon monoxide plus water plus heat. So this happens when there is insufficient amount of oxygen. So when ethene reacts with oxygen, which is not in good amount, or it is insufficient, this will produce carbon monoxide plus water. And to balance up that equation, we're going to put a 2 there, we're going to put a 2 here, we're also going to put a 2 there. Let us look at another point. So another point that we can say is that the alkenes are not as reactive as the alkenes. This is because the alkenes, they don't contain a carbon-carbon double bond. So we can say the alkenes are much more reactive, than the alkenes. And the reason why the alkenes are much more reactive than the alkenes is because they contain a carbon-carbon double bond. And we're going to look at the first process. So they can undergo hydrogenation, so the alkenes can undergo hydrogenation, and hydrogenation is just the addition of hydrogen to a substance, and we're going to use ethene. So if ethene undergoes hydrogenation, what is going to be produced? So this reaction can be in the presence of heat, pressure, and the catalyst. And when the alkenes undergo hydrogenation, they'll produce the alkenes. So here the alkene that is going to be produced will be ethane, so we have our ethene, and if ethene undergoes hydrogenation, which is the addition of hydrogen, that will produce ethane. So the alkenes can also react with water, and this process is referred to as hydration or hydrolysis. So the addition of water is referred to as hydrolysis or hydration. So hydration or hydrolysis is the addition of water to a substance, and we're going to use our alkene, which is ethene. So when alkenes undergo hydrolysis, they'll produce an alcohol. So let us take a look at this reaction. So when the alkenes undergo hydrolysis, they're going to produce alcohols, and we have used ethene as our example there. So if ethene undergoes hydrolysis, that is going to produce ethanol, and ethanol, it's an alcohol. So whenever an alkene undergoes hydrolysis, it will produce an alcohol, and whenever an alkene undergoes hydrogenation, which is the addition of hydrogen to a substance, it will produce an alkane. So as you can see, these types of reaction that we have said, these reactions are referred to as additional reactions. In additional reactions, they turn unsaturated alkenes into a saturated compound. So as you can see, these are two types of reactions that I've given you. The hydrogenation and hydrolysis are referred to as additional reactions. And additional reactions, they turn the unsaturated alkenes into a saturated compound. And as we can see from the hydrogenation process there, we have our hydrogen there. So when hydrogen is added to ethene there, this will produce ethane, and ethane is a saturated hydrocarbon, and the reason why ethane is a saturated hydrocarbon is because it is formed of a carbon-carbon single bond. As you can see, this is carbon-carbon single bond. And if we look at the process of hydrolysis, and hydrolysis, we start with ethene, and we know that ethane has a double bond. It has carbon-carbon double bond, and if we react it with water there, it will produce ethanol. But if we look at the structure of ethanol, we don't have a carbon bond. We don't have a carbon-carbon double bond, and that means that this is unsaturated hydrocarbons. So we can say that addition reactions, they turn unsaturated alkenes into a saturated compound. So let us look at polymerization. So we are looking at polymerization under the alkenes. So the alkenes molecules undergo a very useful addition reaction where they add on to each other to form compounds with very long carbon atoms. So the alkene molecules are called monomers. So we can say that the alkene molecules are called monomers. Then the long chain compounds that form are called polymers. So the polymers are the long chains that are formed. So these are long chain compounds that are formed. And the reaction is referred to as polymerization. So this reaction that helps to join the monomers to form the polymers is referred to as polymerization. So the reaction is called polymerization. And let us look at an example there, and we are going to use ethene as our monomers. So if we have these monomers, so if we have these ethene molecules, and these ethene molecules, we can say that they are monomers. So we can call these as our monomers. So when these they add up on each other, they'll form a polymer. So if they undergo polymerization, this polymer will be formed. And for you to draw the structure of the polymer, you need to use the ethene molecules. So we have how many ethene molecules? We have 1, 2, 3, 4. So the first thing that we're going to do is to draw this first ethene molecule. And since we have drawn this ethene molecule, we're going to put our hydrogen atoms. Then we're going to connect it with another bond there. And you must know that when drawing your polymers, the double bond there is going to break. So we are going to add another ethene there, which is our second ethene molecule. So we're going to put our carbon atom and another carbon atom, and we're going to write another, we're going to write the hydrogen atoms. So for the other ethene molecules, just repeat the process. So this is going to be our polymer. And for our polymer, the number of carbon atoms must be equal to the number of carbon atoms in our monomer. So we can count how many carbon atoms are in our monomers there. We have 1, 2, 3, 4, 5, 6, 7, 8. And if we count here the numbers that we have 1, 2, 3, 4, 5, 6, 7, 8. So this is a collect polymer, and the name of this polymer that's going to be formed, it will be polyethene. So that's going to be the name of this. So let us look at a test for unsaturation. So a test for unsaturation, and we can use bromine water to test for unsaturation. So you can use bromine water to test whether a hydrocarbon is unsaturated. So it is an orange solution of bromine in water. So the color it's orange. So if a carbon-carbon double bond is present, an addition reaction takes place and the color disappears. And when the color disappears, you're going to know that that hydrocarbon is a unsaturated hydrocarbon. But if the color does not change or the color remains orange, that means that that hydrocarbon, it's not unsaturated hydrocarbon. And we are going to use ethene to explain this process. So we're going to draw the structure of ethene. So we have ethene, and ethene is this is colorless. So this when it reacts with bromine, which is in aqueous form, and the color there it's orange. This will produce this compound. So this compound, you can see this compound, it's 1, 2 dibromo. This is 1, 2 dibromo ethane, and this will be colorless. And the reason why this is referred to as 1, 2, as you can see, one bromine atom is on this first carbon atom, which is the first one, and another one is on the second one. So we have 1, 2, and how many bromine atoms do we have in the compound? We have 2, and 2 represents di, so that's going to be 1, 2 dibromo ethane, and this will be colorless. And when this happens, that means that we have tested for unsaturation. But for example, if we use ethane instead of ethene, if we use ethane, the solution is not going to turn to a colorless solution, and you're going to know that that compound is not unsaturated hydrocarbons. But for the alkenes, since they turn into a colorless solution, that means that we have tested that these are unsaturated hydrocarbons. Let us now look at the isomers. So isomers under the alkenes, and we actually said that isomers are compounds that have the same formula but different structures. So isomers under the alkenes, we said that these are compounds that have the same formula but different structures, and we're going to use benzene to explain that. So benzene can be drawn in this form. So another compound that can have the same formula with benzene can be drawn in this form. So we can have the double bond there, then we can have the carbon atom, and we can have another carbon atom. So we can put hydrogen atoms there, and we can actually get this part and draw it here on the middle. So we can get our carbon atom, which is this, and put it here, and we can place these hydrogen atoms. And since this carbon atom is not connected to this hydrogen atom, we can actually place it on top there, and we can write down the rest of the compound. So as you can see, these two compounds have the same formula, and the formula is C. How many carbon atoms do they have? 1, 2, 3, 4, and they have 8 carbon atoms. So let us just count 1, 2, 3, 4, 5, 6, 7, 8, and here 1, 2, 3, 4, 5, 6, 7, 8. And the name of this compound can be written as 2-methylpropene. So this is 2-methylpropene. So we can say that benzene and 2-methylpropenes are isomers of each other. So where you have questions, make sure you ask in the group. So next time we're going to be looking at the alcohols and the carboxylic acids. Thank you.